Mommy made me junk food for Halloween to bring you guys, so she made a lot. There's like 3 or 4 treats per person. I'm eating my favorite, peat marshmallows covered in chocolate on the back. Hi, Alyssa. Good question. So I'm going to actually type this into the chat box. So there's alkane, right? And if you had an alkane with a carboxylic acid, I'm adding spaces for clarity here, right? So all you're doing is cutting off the E at the end, right? So if you have an alkene or an alkyne, okay, then you're just replacing, hi Sarah, you're just replacing the A and E with the E and E or the Y and E. And so it just keeps going at the end the same way it does in all those. Does that like... Now you don't have to put all those spaces in, obviously. You only put them in if there's numbers, but I thought it would make it easier to see. Also, let me know if you can hear me okay. I have Twinkie with me, so you might get some Twinkie cam here tonight. We didn't learn about tert, iso, sec, or in. So don't worry about those. We didn't learn about them. Alyssa, so like if you have hexane, it means there's no double bonds. Hexene is a double bond. So you get rid of the AN. E, and you replace it with E and E, so hexene-oic acid. So you could have like hex-2-ene-oic acid. Like that could be a molecule. So you're taking out the A and E, right? You're taking out the A and E and replacing it with E and E. And then if you have to add a suffix after that, like an OL or an AL or oic acid or whatever, you just take the E off. You just keep that pattern. Just keep the E off. I need to make that bigger. Yeah. Like, I think when you see it, it's like, oh, duh. But, yeah. So, name that molecule. Where you put the alcohol and cyclopentanol. So, if it's a ring, it's oftentimes not numbered if there's just one thing on it, because by definition, it would have to be at carbon 1. So if I have, let me show you. There we go. So if I have cyclohexane, and I just put an NH2 on it, so cyclohexanamine, right? Or cyclohexanol if you wanted to use the alcohol or whatever you want. As long as it's the only thing on there, it's at carbon 1, right? So with rings, they're usually not named, numbered. And then with aldehydes and carboxylic acids, they're not numbered either because by definition they have to be at the end. And so that would be carbon 1. Parent chain is butane, but2-enamine. Where's the amine? Was the amine at carbon 1, carbon 2, carbon 3? There you go. You got it. Now, if I have Chem Sketch, and we'll learn about this like Wednesday. With Chem Sketch, if I have them name this, it'll number it the other way. Because the amine has priority. And so we'll just have to learn that really fast. So if you're trying to practice these on Chem Sketch and you're like, oh, I'm sorry, that should be 1-enum. You caught me with a boo-boo. I'm sorry. I was just writing down what you did. But yeah, if you are trying to like follow this and do it in Chem Sketch and you're like, what does Chem Sketch say the name is? And it has it numbered backwards. It's because of a rule we haven't learned yet. So, you know, I wouldn't count you wrong because we haven't learned it yet. Now, Sarah, like what you were asking, let me circle that one, and this is just under Tools, Generate Name for Structure. So if you notice, they didn't put any number with it because it's at the end. And if you had if you have a carboxylic acid, whoa, it won't number that one either. So, don't follow me, okay. More questions? I'm scooting. Scoot, 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 scoot. Oh no. Scoot, scoot, scoot. I just didn't want to have to delete it all yet. More questions? Some examples of more mechanisms. I can. It's going to look pretty much the same as all the other ones we've done, though. So, like, let me give you something else. Because with the acid-base stuff, it's just something grabbing a hydrogen and the hydrogen breaking off over and over and over and over and over again. So, I mean, I can show you one of those, but I don't think it would be really useful since you've already seen it. So let's say I have this, and H minus. So here's a reaction, all right? So I want you to, this is just kind of a thought problem. Sorry, I hurt my toe. This is kind of a thought problem. So I want you to look at this reaction. If you can do this, then we're in good shape with mechanisms, okay? And I want you to think about what is happening. Like what bond is breaking, what bond is making in this reaction. It's actually the first one we're going to learn when we start doing reactions next week. And then I'll do like an easy one down here too if you just want to do a simple acid-base problem. So do like HNO3. Oops. Other window. Oh, there it is. Hi, Mom.
Hey,
you want to say hi to my class?
Huh?
You want to say hi to my class?
Oh, not particularly,
Oh,
but...
they don't want to. She doesn't want to talk to you.
Oh, no, it's not that. They have studying to do.
Yeah, I know. They're studying. I'm going to give you one that's kind of a harder acid-base problem because it's got, oh goodness. I like keep clicking the button and it doesn't turn off because it has so many different oxygens in it. Annie says hi, Dr. Mann's mom.
Who, what?
My student said hi, Dr. Mann's mom. They called you
Hi,
Dr.
student of Professor Mann.
There's my mom cam. They can see me so they can see you.
I figured as much.
Twinkie's leaving me too. It's an exciting night in the Mann home. I just hear one of my dogs downstairs sounds like she's like falling all over the place. Which she probably is. Onyx is kind of special. So Sarah, Alyssa, and Annie, the people available, and whoever else is on here, let me know when you want me to do the answers to these. I was giving you time to work them out. I know there's a delay, so. Hi, Onyx. That's Onyx. Hi, Onyx. Like, I don't know if our reception is bad or if you guys are just being really quiet. Because I'm not seeing anything pop up. Let me... Sarah, are you still there? Are you still with me? What are you doing? Okay. Okay, you're being quiet. Good. I mean, you can not be quiet. I don't care. It's just... sometimes I worry that I'm not getting the feed, you know? Okay. So let me do it this way. I think I can probably copy and paste this into, oops, paint. I can. Look at that. Okay. Let me swap over. Aha! Okay. So hopefully you can see that okay. Maybe I need to make it a little bigger. That's funky. Okay. Sorry, it's a little pixelated, but it is Microsoft Paint, so let me grab a paintbrush and kind of a fat line and something that's not black so it's easier to see. Okay, so when I look at this, I think of a couple things. Number one, I have to break that bond there, the carbon-bromine bond, and I have to make the bond right there between the oxygen and the carbon. So if you looked at that and said, that needs to happen, then you're correct. Okay. Then, how that happens is nucleophile attacks electrophile, right? So if you drew something like this, where the OH, and that's supposed to have a negative charge, it didn't come over real well. So if the negative charge attacks that carbon and the bromine comes off, then you would get that product. So the bromine couldn't attack anything, right? I mean, it has electrons on it, so in theory it could attack something, but the product that we saw, that would not go with it. Hi, Caitlin. And then, let me know if you got that one right, Sarah, or if you guys got close, I'm curious. That one was a little harder since we hadn't learned it. Then for the nitric acid, you have to draw the Lewis dot structure so we can see it. Nitric acid's kind of weird because the nitrogen and one of the oxygens has a formal charge on it. Okay. So in this case, right, it's an acid-base reaction, so we have to be able to recognize which one's the acid and which one's the base. Nitric acid is on our list of strong acids, right, which means its pKa is less than 0, and we know that water is right around 15, which means nitric acid, right, you see a trend? Nitric acid will be our weak, or well, it'll be a strong acid, and then our water is going to be our base. So what do I get if I do this? Let me scroll this down a little. So let's think about what this reaction would be, okay? And I know that, you know, you guys have been seeing how this could be difficult, right? Like you could get the products, but not the mechanism on how to get there. So if water is my base, that means it's getting a proton, right? Well, in nitric acid, there's only one hydrogen to come off, so that makes that one kind of easy. And I'm just going to show nitric acid in its conjugate base form, nitrate, plus H3O plus. Okay, conservation of charge. We added a negative, have to add a positive, right? So how does this mechanism happen? Let me pull this up with green. Okay, so, well, let me do something in case people are colorblind. It's unlikely, almost the entire class is women, but who knows. Okay, so if we had on our list of nucleophiles that bases are nucleophiles, right? Sorry, hold on. I have to adjust my foot. So if bases are nucleophiles and acids are electrophiles, right? And we think about what's happening, we have to form a bond between that oxygen and that hydrogen, and we have to break the bond between that oxygen and hydrogen. Okay. So how can we do that? Well, this guy over here has, this is really hard to show, sorry, has 2 lone pair of electrons, so four unpaired electrons, not unpaired, 4 non-bonding electrons. And so it can go and attack the hydrogen, forming the oxygen-hydrogen bond, which we see in the product. Okay. At the same time, that would make hydrogen having 2 bonds to it, so we have to break one of those. And we get that there. And that would put a negative charge on the oxygen because we're adding an extra lone pair of electrons. Right? And so now its valence is 7, giving it a negative charge. So let me know how you did. Oh, we've been missing some of that box. I'm sorry. Let me fix that. I just thought it wasn't updating. I didn't realize we were... I'm glad you did good. You want to do another one? Let's do another one. Oh God, the big dog's coming. Hi, Red. So I tell you guys about my big dog. When I say big dog, he's gigantic. He's like the size of the Titanic. He's 110 pounds and like 8 feet long. And he comes up to my hip. Held for review. Nicole, it didn't want to put your comment on there. I think they thought it was dirty. It made me review your comment and hit okay. Oh, I'm kind of blushing now. Hold on. Oh gosh. It just took me like 15 seconds to figure out what was going on, and now I feel dirty. Okay, let's do another example. Okay. I'm just going to go ahead and keep doing this on the paint because I think that works well. For mechanisms, it's easier to show them quickly. So let's do... Oh, wait. And with mechanisms, it's best to show all the bonds, so that way you can actually show all the bonds making and breaking that you need to. Otherwise, it's hard to do and you probably won't get full credit for it. So always show your bonds if you need to for making and breaking. Like I can't just do, for example, H2O and have something going like this. Like that doesn't really mean anything because you're not really showing anything. That's a bad plus sign. Let's try that again. All right, so there's an acid. I need a base. Let's do... Let's do a really strong base, sodium hydride. So, tip. Remember sodium hydroxide is in a plus and OH minus. So sodium hydride is sodium with an H minus, right? Really good base, really good nucleophile. So what would be an electrophile? Well, acids make decent electrophiles. And here we have a carboxylic acid. Why is it electrophile? Well, the oxygen has a partial negative charge. The hydrogen has a partial positive charge. So does this carbon and oxygen. And we'll see examples in the semester where the carbonyls, the CO double bonds, will do things. But right now we haven't learned those yet, so we're just doing acid-base chemistry. Okay? So think about your sodium hydride as H minus, and that is your nucleophile, and it's a base. So tell me what you get. I'm going to erase a little bit of that because otherwise it's going to be hard to... I feel like I should say something since I'm just kind of drawing. Okay. Let me do it this way. All right. So what do we have going on here? I need to form a bond. Let me make it bigger size. I need to form a bond between those two hydrogens, right? And I need to break the bond between the oxygen and hydrogen. Partial positive. No, you don't. Caitlin, you do not need to represent all partial positive and partial negative charges. Now, it would be fair game. I could ask you to show me partial positive and partial negative charges, but if I don't ask for it, you don't have to do it. Okay. So, nucleophiles attack electrophiles, bases are nucleophiles, acids are electrophiles. So I'm going to go ahead and do that. Now, you can show this of two ways. That hydrogen's negatively charged because it's got a lone pair of electrons on it. So you can either show it from the hydrogen or the electrons or the negative charge. I usually go from the negative charge. Okay, and then we break the bond on that oxygen. There you go. So this first one here, number 1, is what made that bond there. And the second one there is what put an extra lone pair on that oxygen. Make sense? Caitlin, I just got your email. I'm sorry I didn't have my email up. I see that you have found us, so. Whew, pardon me. Long day. Hi, David. Sodium becomes a spectator ion. Yeah, that's correct. And, I mean, if you want to, you can show it. It's going to be counterbalancing the charge on that oxygen, right? So, it started up here as the counterbalance to the hydride, and now it's balancing out that, it's called a carboxylate anion. I'm not worried if you show them or not. If you want to show them, you don't get counted off. It's not incorrect. As a general rule, most organic chemists, I'd say they don't tend to show non-carbon things that like aren't part of the reaction. Also, if you have something like that, hydrogen gas is a gas, so sometimes you'll see it like this, where it's like leaving, bubbling out of the solution, or sometimes you'll see it with a little arrow next to it, meaning it's going up out of the solution. Just, if you're ever looking at something online, I know you guys use a lot of online resources. If you see something like that, that's where that's coming from. Your all's exam is written. It is finished. I'm bringing snack food tomorrow, so if you need to snack during an exam, if you're a stress snacker, you can have some snacks. I got the NaH2, is that wrong? So if you show it, that's a good question, Caitlin. Let me scroll down a little. If you show it like this, that is incorrect, okay? Because the sodium is no longer complexed to the hydrogen. It is now balancing the charge on the carboxylic acid, or what used to be the carboxylic acid. Now, something you can do, if you want to show it that way, is to say sodium plus, which is indicating it's in the ionized form, plus H2, because that's two different things then, right? That's not indicating that they're stuck together. So if you like to put all those in there, you can. The other way is you could draw it like this. That's also acceptable. I don't usually show it that way, but if you like it that way, then you can show it that way. Because it's the sodium is forming an ionic interaction, right, with the oxygen that has the negative charge on it now. Negatives stick to positives. You know how it works. Okay. Go and do another one. So this is called a carbanion. Because it's a carbon anion. Carbanion. let's put in methanol. Okay. So if I tell you that this is a good nucleophile because it's a carbanion, you're like, okay, what's my product going to be? Let's do so this is an acid-base reaction, but it's not one that is one we've seen. Sorry, my lone pairs are like little dashes, so I'm getting them to show up. And yeah, we can do a stereochem next. I think y'all wore me out today. Keep yawning. Okay. So nucleophiles attack electrophiles every time, no exceptions. Every time nucleophile attacks an electrophile. So nucleophile attacks an electrophile. Well, what's the electrophile over here? I've got a hydrogen that's got a partial positive charge on it, and a carbon with a partial positive charge on it. So in theory, it could grab either. I'll tell you, based off of the product, you should be able to see that it does an acid-base reaction because it does a proton transfer. So we're basically having to make, let me do the thing where I change the color. We have to make a bond from that carbon to the hydrogen to make this down here, right? And then we need to break the oxygen-hydrogen bond, giving us a lone pair of electrons on the oxygen. And I just randomly circled one. It could be any of the three lone pair. It doesn't matter. My dog's being special. So nucleophile attacks electrophile, bond breaks, gives us our two products. Okay? So I'm going to switch back to Chem Sketch. And if you guys have questions on that, then let me know. It's always so weird when I'm quiet and doing this. And then I need to make something chiral. I'm sorry, they're clicking around a lot tonight. Ionics. Smushing your cute face, Onyx. Alright. So, somebody work out what the stereochemistry is of what I just made it. What are you doing? guessing we're cut off again. Sorry, I fixed it on the one screen and not the other. Okay, well, let's figure it out. I didn't actually work it yet, so let's do the nitrogen as number 1, right? Carbon number 2 would be this carbon down here in the middle. Number 3 would be the carbon over there. Number 4 would be the hydrogen. So that makes my stereochemistry. I hate drawing arrows on this program, sorry. I connect 1, 2. If I go that direction, I have an arrow menu. There we go. So I agree, that's R. Then the one on the bottom, the bromine would be number 1, right? I'm also going to label that yellow. Number 2 would be the carbon up here on the parent chain. Number 3 is the methyl group. And number 4, again, is the hydrogen, which it always is. So then if I connect those, oh my gosh, Onyx, I don't know what you want, honey. She's being kind of needy tonight. I don't know what her deal is, sorry. She keeps like running into me trying to get me to pet her. So that's also R. So David and Annie, you get a star. Very nice. So I want you to think about how you could draw the enantiomer of this. So what would the stereochemistry of the enantiomer be, and how would you go about drawing it? There's more than one way. I'll give you a second to answer in your mind or on paper. Yes, Caitlin, those are both options for you. Team mirror image. And, you know, it just depends on what y'all see better, you know. So if you're finding that one way is easy for you compared to the other, then do it the way that's easier for you, you know. Don't make it hard on yourself. So, team switch too. Let me pull this up over here. Okay. Copied and pasted into Paint. So if you are on Team Mirror Image, I'm gonna draw my mirror plane here. And then I'm just going to draw the exact mirror image of my molecule, right? I've got something like that. Got my methyl group there. I'm calling it a methyl group, but it's not really a methyl group, right? It's like part of the parent chain. And not like it's like part, I mean, it is part of the parent chain. You'll notice here, let me see if I can kind of highlight this, that right here and right there, I'm going H2N and H3C, so that the bond is actually connected to the atom rather than looking like it's attached to hydrogens. That's a picky thing a lot of us do. Hydrogen and bromine. So if you want to work it out, that's fine, go for it. But if this was RR and I drew the mirror image, that has to be SS, right? Now, if you are on Team Switch 2, so if we wanted to do the SS, I could either go it this way or let's do it another way, where, you know, for me, I just kind of draw out the skeleton of this. and then I flip 2 groups, and it doesn't matter which 2. So I'll probably keep my CH3 groups just because, I don't know. I have to keep something, right? And then I flip the other 2 groups. So hydrogen and nitrogen. And then the bromine and hydrogen. Okay. So switching 2 like that, and I'm sorry, that C looks terrible. That's one way to do it. Sorry, David, I just saw your comment. Now, if we wanted to take our SS image here, and we'll say this is S1 and S2 down there. Okay. So Annie, hydrogen has to be drawn behind to be able to tell what the stereochemistry is by using that clockwise, counterclockwise thing we've been doing. Okay, so that's a convention that we use to teach you how to determine RS stereochemistry. But you could draw the molecule any way you want, okay? And if you're flipping 2 groups, then, you know, you can basically draw it any way. It's essentially the same as drawing the mirror image, okay? Yeah, I know what you're talking about, David. But so let's look at the S1 and the S2. So we have 2 SS down here at the bottom. And if I wanted to convert that to RS, I hope that made sense, Annie. So RS, all right. Oh, and Annie, if you want, if you're really wanting to make sure that you can double check your work and make sure that you can tell the stereochemistry when you do flip 2 groups, then flip the other 2. Flip like the methyl and the bromine, so that way the hydrogen's still pointing behind. Okay, it doesn't matter however you want to do it. Okay, so the R and the S, how would you go about doing that? Different color, please. Okay. So if we know that this is R, and that's R, and we know that this is S, S, and that's SS. Annie, it depends on actually how the molecule is named and numbered when you name it, like the way that we do for naming, where we find the lowest possible numbers and things, but we haven't really been working on that. So could I pick any R and attach it to any S? Yeah. So if you wanted the RS, where you were basically looking at the amine carbon up here, if you wanted that R, then just use the one up there that's already R stereochemistry, and then attach it to the bottom of one of these, which are both S. Or, if we go back to Team Flip It, if I know that this one down here is S, I just have to flip 2 groups on this top part, right? So, draw a skeleton of that. Khan Academy made what complicated? I'm glad you're telling me that. It means you're at least still paying me for a reason. All right, so let's flip two groups, CH3 and hydrogen. That's how we would get SR. Oh, shoot, I was trying to get RS. Sorry. Okay, so I used this one down there, and then at the top I just have to flip two groups to go from the S to the R. So now that is R, and that is S. Well, I don't know. I mean, you've been watching me type it out, you know, draw it out, so it probably doesn't look too complicated, but if someone just, like, opened up a screen right now and they came into this conversation, they'd be like, what the holy hell is that? It would be so confusing. Like, what are all these letters and lines and circles? This color coding makes no sense. I try. Any last questions? I'll give you one more. And, you know, I'll still answer emails for a few hours, if you have any. Let me actually double check my email real quick to make sure nobody from class is trying to get in touch. Okay. What are you doing, Red? My dog has, like, curled himself around my chair that I'm in. Alright, you guys are being quiet. I'll go ahead and hop off then. Email me if you need any help tonight. Okay, I'll still be up for a few hours working. By working, I'm not working anymore tonight, but I will be, you know, answering emails if you guys have them. Your exams are typed up. Those of you who take them over in ODS, I've gotten them over in ODS. They got over there. So, in the email I sent them, if you go over there, because I know there's a few people in class that take their tests over there. If you go over there, I put in the test that you can use a periodic table and a model kit. And I told them that you can come up with a pre-made molecule. So if you come in with like a cyclohexane made, or if you come in with, you know, a couple chiral carbons ready to go, so you don't have to take time to do that on the exam, that's fine. And they should be okay with that. But I think if that's an issue, let me know. Like, have them contact the office, the chemistry office, if I'm not in my office, and Miss Donna can get in touch with me on my cell phone. Like, tell them it's urgent. Like, you should be able to use a model kit. I don't think it'll be a problem, but just in case it is. And then I guess that's it. I'll be around tomorrow during the middle of the day for a little bit. If you guys have any questions, then you can run by me. I'll probably take lunch at some point, but I'll see you guys tomorrow, okay? Good luck studying tonight. Exam's 4 pages, got some nomenclature, got some acid-base reactions, got some mechanisms, got that same kind of stuff on it that we're used to seeing. So have a good night, everyone.